In a climate-controlled facility no larger than a standard two-car garage, a single entrepreneur can raise and harvest 5,000 quail every single month. That is 60,000 birds per year, producing over 12,000 pounds of meat and hundreds of thousands of eggs from a space that could fit inside most suburban backyards. These tiny birds, each weighing less than 6 ounces at maturity, are revolutionizing how Americans think about small-scale farming and urban agriculture. But how do you manage thousands of birds in such a compact space? What kind of automated systems allow one person to feed, water, and monitor an entire flock without spending every waking hour on farm chores? And why are savvy agricultural entrepreneurs choosing quail over chickens, ducks, or other traditional poultry? Welcome to AgriCraft, where we explore innovative approaches to modern agriculture and food production. Today, we are diving deep into the world of commercial quail farming, a micro-poultry operation that is perfectly suited for urban and suburban entrepreneurs who want to break into agriculture without massive land investments or industrial-scale infrastructure. This is farming reimagined for the 21st century, where technology meets biology in operations so efficient they are rewriting the economics of small-scale meat and egg production. All will be revealed in this video. Quail have been raised for food and sport for thousands of years. Ancient Egyptians documented quail hunting along the Nile, and Japanese farmers began domesticating quail for egg production over 800 years ago. The species most commonly raised in American agriculture is the Coturnix quail, also known as Japanese quail, which was selectively bred in Japan starting in the 12th century, specifically for high egg production and rapid growth rates. Commercial quail farming in the United States remained relatively niche until the past 2 decades, when several factors converged to make it increasingly attractive. Rising land costs made traditional poultry farming economically challenging for new farmers. Urban agriculture movements created demand for locally produced protein that could be raised within city limits. And perhaps most importantly, consumers began seeking alternative proteins that were more sustainable and ethical than industrial chicken or beef production. Here is something that surprises most people. A quail reaches harvest weight in just 6 to 8 weeks from hatching, compared to 8 to 12 weeks for chickens. Quail hens begin laying eggs at 6 to 8 weeks of age and can produce over 300 eggs per year. That productivity in such a compact package makes quail one of the most efficient protein converters in all of agriculture. For every pound of feed consumed, quail produce nearly 1 pound of body weight or the equivalent in eggs, a conversion ratio that rivals or exceeds that of chickens. The economic relevance of quail farming extends beyond simple protein production. Quail eggs sell for premium prices, often $3 to $5 per dozen compared to $3 to $4 for chicken eggs. Quail meat, considered a delicacy in many cuisines, can fetch $8 to $12 per pound dressed weight, substantially more than conventional chicken. For urban entrepreneurs with limited space and capital, these premium prices, combined with rapid turnover, create business models that can achieve profitability within months rather than years. Globally, quail production is massive. China alone produces over 400 million quail annually, while Japan, where quail eggs are a breakfast staple, raises approximately 20 million birds each year. The United States market is smaller but growing rapidly, with commercial operations now established in California, Texas, Florida, Georgia, and increasingly in urban areas across the Midwest and Northeast, where zoning regulations permit small-scale poultry operations. Every commercial quail operation begins with breed selection. The Coturnix quail dominates American quail farming due to its docile temperament, high productivity, and well-documented breeding characteristics. Within Coturnix, farmers choose between several varieties. The jumbo Coturnix grows larger, reaching 7 to 9 ounces at maturity, making it ideal for meat production. The standard Coturnix, slightly smaller at 5 to 6 ounces, is preferred for egg production due to earlier maturity and higher laying rates. Some operations raise tuxedo or golden varieties for their distinctive coloring, which appeals to specialty markets. Starting a quail operation typically involves purchasing fertilized eggs from established breeding stock or buying day-old chicks from specialized hatcheries. Most serious operations eventually maintain their own breeding flock, selecting the most productive hens and healthiest males to ensure consistent genetics. A breeding flock ratio of 1 male to every 3 to 5 females maintains high fertility rates without excessive male aggression, which can damage hens and reduce egg production. Incubation is the first critical technical step in quail farming. Fertilized eggs are placed in climate-controlled incubators where temperature and humidity are precisely managed. Quail eggs require a temperature of 99.5 degrees Fahrenheit and relative humidity of around 50 to 60% for the first 15 days of incubation. These parameters are not negotiable. Even small deviations of 1 or 2 degrees can dramatically reduce hatch rates or produce weak chicks. Modern incubators designed for commercial quail operations can hold anywhere from 100 to 10,000 eggs simultaneously. The most sophisticated models feature automatic turning mechanisms that rotate eggs several times daily, mimicking the behavior of a brooding hen and preventing the developing embryo from sticking to the shell membrane. Digital controllers monitor temperature and humidity constantly, making micro-adjustments throughout the day and night to maintain optimal conditions. Around day 15, eggs are transferred from the incubator to a hatcher, where humidity is increased to 65 to 70% to soften the shell membrane and facilitate hatching. Over the next 2 to 3 days, chicks begin pipping, breaking through the shell with a specialized egg tooth. The hatching process is staggered over 24 to 48 hours. Once most chicks have hatched and dried, they are removed from the hatcher, sorted by quality, and moved to brooding facilities. Environmental requirements during this initial stage are exacting. Incubation rooms must maintain stable ambient temperatures to prevent equipment from working too hard. Many commercial operations maintain incubation rooms at 70 to 75 degrees Fahrenheit and monitor power supply constantly, as even brief power outages during incubation can destroy an entire batch of developing eggs. Backup generators are standard equipment in serious quail operations. Newly hatched quail chicks, called keets, are remarkably small, weighing less than 1/4 of an ounce. These tiny birds are also incredibly fragile during their first 2 weeks of life, requiring intensive care and precise environmental management. Brooding facilities provide warmth, food, water, and protection during this vulnerable period. Commercial brooding setups typically use stacked brooder boxes or dedicated brooding rooms with carefully controlled heating. Temperature starts at 95 degrees Fahrenheit for the first week and is gradually reduced by 5 degrees each week until birds are fully feathered at around 4 weeks of age. Infrared heat lamps or ceramic heating elements provide consistent warmth without the fire risk of traditional bulbs. Brooding density matters enormously. Overcrowding leads to trampling, increased disease transmission, and stunted growth. Commercial operations typically allow 1/2 square foot per chick during the first 2 weeks, then increase space as birds grow. Bedding material, usually pine shavings or specialized paper products, must be kept dry and clean. Wet bedding promotes bacterial growth and respiratory problems that can devastate a flock within days. Feed and water systems during brooding require special adaptation for tiny birds. Quail chicks can drown in water containers designed for chickens. So shallow waterers, or specialized nipple drinkers, scaled for small birds, are essential. Feed is provided as a high-protein starter ration, typically containing 28 to 30% protein compared to 18 to 20% for chicken starter. This protein density supports the explosive growth rate that sees quail reach 20 times their hatch weight in just 6 weeks. Quality inspection starts immediately after hatching. Chicks are visually sorted, with weak, deformed, or undersized individuals culled. This sounds harsh, but is essential for maintaining flock health and productivity. Commercial operations cannot afford to invest, feed, and space in birds that will never reach productive maturity. The culling rate in well-managed operations is typically 5 to 10%, though operations with poor breeding stock or incubation management can see rates above 20%. Automated systems increasingly dominate even small-scale quail operations. Programmable thermostats maintain precise temperature ramps. Automatic waterers connected to pressurized systems ensure constant access to clean water. Some advanced setups use sensors that monitor temperature, humidity, and even ammonia levels from bird waste, alerting farmers via smartphone apps if conditions drift outside acceptable ranges. At around 2 to 3 weeks of age, partially feathered quail are moved from brooders to grow-out facilities where they will remain until either harvest for meat or transfer to laying facilities for egg production. This transition represents a critical moment in commercial quail farming, as birds are now hardy enough to handle less intensive management but still require careful attention to environment and nutrition. Grow-out housing in efficient quail operations almost always uses stacked cage systems. Unlike free-range chicken farming, commercial quail do remarkably well in cage systems specifically designed for their size and behavior. A typical cage might measure 2 feet wide by 4 feet long by 8 inches tall, housing 20 to 30 birds depending on whether they are being raised for meat or eggs. These dimensions provide adequate space while maximizing vertical space utilization, allowing thousands of birds to be housed in remarkably compact facilities. Cage construction uses welded wire mesh with 1/2 inch or 3/4 inch spacing, allowing waste to fall through to collection trays below while preventing foot injuries. The cages are stacked 4 to 6 levels high with dedicated waste collection systems beneath each level. Some operations use simple removable trays that are cleaned daily or weekly. More sophisticated setups feature sloped cage floors and conveyor belt systems that automatically remove waste, dramatically reducing labor while improving hygiene standards. Feed and water delivery in grow-out facilities shifts to automated systems. Long feed troughs run the length of each cage, filled either manually or by mechanized auger systems that deliver measured amounts of feed on programmable schedules. Quail consume approximately 20 to 30 grams of feed per bird per day, so a facility housing 5,000 birds requires 300 to 400 pounds of feed daily. Bulk feed storage and automated delivery systems transform what could be hours of daily chores into minutes of system monitoring. Water delivery typically uses nipple drinker systems where birds peck at small metal stems that release water on demand. These systems prevent spillage, keep water clean, and allow precise monitoring of water consumption. Changes in water intake often provide the first warning of disease or environmental stress, making monitoring systems valuable management tools. Temperature control in grow-out facilities aims for consistency rather than the precise heat required in brooding. Most operations maintain temperatures between 65 and 75 degrees Fahrenheit, though fully feathered quail can tolerate a much wider range. Ventilation becomes increasingly important as birds grow. Each quail produces surprising amounts of moisture through respiration and waste. Without adequate air exchange, humidity climbs and ammonia from waste accumulates, stressing birds and increasing disease susceptibility. Lighting programs influence growth rate and productivity. Meat birds typically receive continuous or near-continuous lighting to encourage constant feeding and maximum growth. Laying hens require 14 to 16 hours of light daily to maintain peak egg production. Many operations use programmable LED systems that can adjust light intensity and duration automatically, simulating natural day-night cycles or manipulating photoperiod to optimize productivity. Quail raised for meat reach optimal harvest weight at 6 to 8 weeks of age when they typically weigh 5 to 7 ounces live weight. Timing the harvest correctly maximizes meat yield while minimizing feed costs. Birds harvested too early produce less meat per bird. Birds kept too long past optimal weight consume feed without proportional weight gain, reducing economic efficiency. Harvest day in commercial quail operations involves careful planning and execution. Birds are typically fasted for 8 to 12 hours before processing to empty their digestive systems, reducing contamination risk during processing. Many operations conduct harvesting in the early morning, processing birds quickly to maintain meat quality. Small-scale operations often process birds on-site using manual methods. Birds are humanely dispatched using cervical dislocation or specialized killing cones that restrain birds while allowing quick, humane slaughter. Scalding follows immediately, with carcasses dipped in water heated to 125 to 140 degrees Fahrenheit for 30 to 45 seconds. This loosens feathers for plucking. Manual plucking is labor-intensive but feasible for smaller operations processing 50 to 200 birds per day. The wet feathers are rubbed off by hand, a process that takes 1 to 2 minutes per bird for experienced processors. Larger operations invest in mechanical pluckers, essentially rotating drums lined with rubber fingers that remove feathers through friction as birds tumble inside. These machines can process 5 to 10 birds at once, dramatically increasing throughput. After plucking, birds are eviscerated, removing internal organs. This step requires skill and care to avoid puncturing intestines or bile ducts that would contaminate meat. The carcass is opened, organs removed, and the body cavity rinsed thoroughly. Quality inspection happens continuously, with processors discarding any carcasses showing signs of disease, injury, or contamination. Some operations offer whole-dressed birds, while others further process into boneless breast meat, legs, or ground meat products. Larger commercial processors use industrial machines designed for small poultry, though much equipment must be adapted from chicken processing and scaled down. Automated eviscerators, washing systems, and grading equipment streamline processing, but most quail operations remain more labor-intensive than chicken facilities due to the smaller scale and specialized nature of the product. For operations focused on egg production, harvest means daily egg collection rather than bird processing. Quail hens begin laying at 6 to 8 weeks of age and maintain high production for 1 year before declining. A productive hen lays 5 to 6 eggs per week, approximately 250 to 300 eggs annually. Egg collection in efficient operations happens on automated or semi-automated systems. Cages are tilted slightly toward the front, and eggs roll gently onto collection trays or conveyor belts that run along the front of each cage row. Some facilities collect eggs manually 2 or 3 times daily, walking along cage rows and gathering eggs into baskets. Others use mechanized collection where eggs roll onto belts that transport them directly to a central processing area. Fresh quail eggs require careful handling due to their delicate shells, which are thinner and more fragile than chicken eggs. Collection systems must prevent eggs from rolling too fast or dropping too far, either of which can cause cracks. Automated systems use padded collection points and gentle transitions to minimize damage. Quality inspection for eggs involves candling, where eggs are held against a bright light to reveal the interior. Infertile eggs, those with blood spots or cracked shells, are removed. Commercial operations typically see 90 to 95% of collected eggs pass initial quality inspection, with rejected eggs used for animal feed or compost. Once collected, eggs move to processing areas where they are cleaned, graded, and packaged. Quail eggs almost always have some fecal matter or debris on the shells from the cage environment. Cleaning must remove contamination without compromising the egg's natural protective coating or introducing bacteria into the porous shell. Many small operations use dry cleaning methods, brushing eggs gently with fine bristled brushes or textured pads to remove debris without water. This preserves the bloom, a natural coating that seals the shell's pores and extends shelf life. Larger operations may use wet washing with specialized egg washing machines that spray eggs with water heated to slightly above egg temperature, typically 110 to 120 degrees Fahrenheit. Sanitizing solutions at very low concentrations may be added to reduce bacterial counts. After washing, eggs are dried quickly with forced air and moved to grading. Grading for quail eggs is less standardized than for chicken eggs, but operations typically sort by size and quality. Premium grade eggs are uniformly colored, properly shaped, and free from defects. These command the highest prices. Second-grade eggs may have minor shell imperfections or color variations but are still perfectly edible and nutritious. Some operations use candling tables with built-in lights for quality inspection and hand-sort eggs. Others have invested in automated grading equipment adapted from chicken egg operations and recalibrated for the smaller quail eggs. These systems can process thousands of eggs per hour, weighing and candling each egg before sorting them into grade categories. Temperature control during and after processing is essential. Eggs warm slightly during collection and processing, then must be cooled promptly to extend shelf life. Most operations move processed eggs directly into refrigerated storage maintained at 38 to 45 degrees Fahrenheit. At these temperatures, properly handled quail eggs remain fresh for 4 to 6 weeks. Though many operations aim for shelf life of 2 to 3 weeks to ensure maximum quality for consumers, packaging for quail products varies dramatically based on market. Whole-dressed quail for meat are typically vacuum-sealed individually or in pairs, then frozen or held under refrigeration. Vacuum packaging extends refrigerated shelf life to 1 week, or frozen shelf life to 6 months, while preventing freezer burn and preserving meat quality. Some specialty operations package fresh quail in modified atmosphere packaging where regular air is replaced with nitrogen or carbon dioxide, extending fresh refrigerated shelf life to 10 to 14 days. Labeling for meat products must include weight, processing date, safe handling instructions, and any required food safety warnings. Many small operations process under state or USDA inspection, which requires specific labeling formats and information. Traceability is increasingly important, with some operations including lot numbers that allow individual packages to be traced back to specific growing cohorts. Quail eggs are packaged in specialized cartons designed for their smaller size. While chicken egg cartons have large wells, quail egg packaging uses smaller compartments, typically holding 12, 18, or 36 eggs. Some premium operations use clear plastic containers that showcase the attractive speckled shells that make quail eggs visually distinctive. Others use paperboard cartons similar to chicken egg cartons but scaled down. Distribution for urban quail operations often focuses on local direct markets. Farmers, markets, restaurants, specialty grocers, and direct-to-consumer sales through community-supported agriculture programs or online ordering represent primary channels. The premium pricing and local production story resonates strongly with consumers seeking alternatives to industrial agriculture. Logistics for quail products are relatively straightforward compared to larger livestock. A compact vehicle can transport hundreds of pounds of quail meat or thousands of eggs. Many operations make weekly deliveries to restaurants and retailers, maintaining cold chain integrity with insulated coolers and ice packs or refrigerated vehicles for larger operations. Some producers have developed value-added products to capture additional margin. Pickled quail eggs, smoked quail egg pasta, and other specialty items transform commodity products into premium offerings. These products often have extended shelf life and higher profit margins, though they require additional processing licenses and food safety compliance. Byproducts from quail farming, while modest in volume, contribute to sustainability and revenue. Quail manure is rich in nitrogen and makes excellent fertilizer for gardens and small farms. Some operations compost manure with bedding material and sell it to local gardeners, creating a secondary income stream while solving a waste management challenge. Feathers from processing are typically composted or used as soil amendments rather than collected for other uses due to their small size. Culinary applications for quail have expanded dramatically as American cuisine becomes more adventurous. Whole roasted quail appears on upscale restaurant menus, often stuffed with wild rice or fruit compotes, and served as individual portions. Quail eggs are featured in appetizers, salads, and ramen bowls, their diminutive size and rich flavor making them popular in fine dining and Asian fusion cuisine. Some chefs appreciate that quail eggs can be perfectly soft-boiled in just 2.5 to 3 minutes, compared to 6 to 7 minutes for chicken eggs. Nutritional value of quail products is impressive. Quail meat contains approximately 25% protein, with less fat than chicken, making it a lean protein option. The meat is rich in B vitamins, particularly B12, and provides significant amounts of iron and zinc. Quail eggs, despite their small size, pack remarkable nutrition. Each egg contains about 14 calories, 1 gram of protein, and notable amounts of vitamins A, B12, and selenium. Some nutritionists claim quail eggs have up to 3 times the nutrient density of chicken eggs gram for gram, though this varies based on the diet of the birds. Environmental impact of quail farming is notably positive compared to larger livestock operations. The space efficiency means more protein production per square foot of land than virtually any other terrestrial animal. Feed conversion efficiency approaches or exceeds that of chickens, meaning less grain is required per pound of protein produced. Waste production per bird is minimal, and properly managed systems generate no more environmental impact than a large dog in terms of waste volume and management requirements. The accessibility of quail farming for beginning farmers and urban entrepreneurs cannot be overstated. Startup costs for a small operation producing 100 to 500 birds monthly can be under $5,000, including cages, incubators, and initial breeding stock. Unlike cattle, pigs, or even chickens, quail can be raised legally in many urban and suburban areas under existing small animal ordinances. The quiet nature of quail compared to roosters and the minimal odor from properly managed operations make them neighborhood-friendly. From the precise temperature control of incubation chambers, where thousands of tiny eggs develop, to the stacked cage systems that house growing birds in spaces no larger than a suburban garage, commercial quail farming represents agriculture perfectly adapted for the modern entrepreneur. We have followed the complete production cycle, the careful breed selection and genetic management that ensures productive flocks, the intensive brooding period where fragile chicks grow under precisely controlled conditions, and the harvest and processing stages where birds become premium protein products for discriminating consumers. We have seen how automated systems for feeding, watering, and waste management allow single operators to manage thousands of birds with just hours of daily labor. We have explored the dual production pathways of meat and eggs, each with their own processing requirements and market opportunities. And we have examined the packaging, distribution, and value-added opportunities that turn this micro-poultry into a viable business model for urban and suburban locations where traditional farming is impossible. The efficiency of quail production is genuinely remarkable. 6-week production cycles, 95% space utilization through vertical stacking, feed conversion ratios approaching 1-to-1, and premium pricing that supports profitability at small scales combine to create opportunities for agricultural entrepreneurs who might otherwise be priced out of farming. This is agriculture technology meeting traditional animal husbandry in a model that proves farming is not just for rural areas with hundreds of acres. Thank you for watching this deep dive into commercial quail farming here on AgriCraft. If you found this exploration of micro-poultry production and urban agriculture inspiring, please give this video a like and subscribe to our channel for more coverage of innovative farming methods, sustainable agriculture, and entrepreneurial approaches to food production. Are you raising quail or considering starting a flock? What questions do you have about small-scale poultry operations? What other alternative livestock or urban farming topics would you like us to explore? Leave your thoughts in the comments below. Until next time, keep innovating in agriculture.